When it comes to addressing devices at layer 3 or the network layer, we tend to use what we call IP addresses. Now these are examples of IP version 4 addresses. IP version 6 is currently being adopted and will be kind of the future of IP addresses, but they follow the same ideas as IPv4. So we're going to look at in more depth at IPv4 addresses. So this is an IPv4 address. You'll notice that it is 4 numbers separated by periods. Now these numbers can range between 0 and 255. You have to think really that an IP address is 32 binary digits. Okay, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. So there we go. So we call these octets because there are 8 binary digits between each of those periods. Now the computer, of course, doesn't put the dots in there. I just put those in so that you can see the corresponding location of the decimal number to where the binary number would be. But we have 32 binary digits that create our IP address. So the largest value that we can hold in 8 binary digits is 255. So this is an example of an IP address, 192.168.1.215. Now the computer, in order to use this address, actually needs some more information. Okay. The net mask here, which is 255.255.255.0, and the default gateway, 192.168.1.1, are necessary for this computer to work on the network. The net mask is what tells the computer what network they are on. We can essentially use a logical AND between the binary representation of this address and the binary representation of the net mask to come up with the network ID. But essentially, any octet that is covered by all ones, or 255, is going to translate down to the same value. So 192 is going to be 192.168.1, and this 0 says that this part is not part of the network ID, so .0. So this net mask separates out the device ID from the network ID, and in fact, in this case, that's the division. Everything over here is the network ID. So all computers on this network are going to have identical bits or the same numbers for this portion. That determines what the network is. On this side is the device ID. This is the 215th device on this particular network. Now the default gateway, you'll notice, has the same network ID. It has the same numbers or the same digits for the network portion of the address, but it has a different device ID. Now this default gateway is essentially the route or the path to get to the internet or to other networks. So the gateway allows us to get from our computer, our network, to another network. It has to be on the same network as our computer, otherwise our computer can't talk to it. Okay? Now when you configure an IP address on a computer, you may have to assign an IP address, in which case you'll also have to assign the net mask and the default gateway. The last piece of information that a computer will need in order to operate with an IPv4 address is the DNS, or the domain name service. These are some examples of some public DNS servers. 8.8.8.8 is the Google Open DNS. And these are servers that when you put in a URL like www.google.com, that request is going to go from your computer out the default gateway. The default gateway is usually associated with a router that can translate from this network out to a different network. And then you're requesting from DNS, requesting the IP address of Google. So if you send out what is www.google.com to 8.8.8.8.8, this server will actually respond with the answer that Google is located at 172.217.8.196 or some other IP address that Google owns. And then you can communicate with Google through the default gateway. So these are the pieces that you'll actually have to assign if you manually assign an IP address. You'll have to give it give the computer an IP address, a net mask, a default gateway, and then at least one DNS server.